Hey everyone, welcome back to a new series where we're going to be learning linear algebra, which is the backbone of data science. Trust me, there is no field in computing where you won't find its application, from machine learning, computer graphics, image processing, and beyond. As a data scientist, it is one of the most important subjects of study. So let's jump straight into the basics by exploring the fundamental concept in linear algebra, the vector. So, what is a vector? We may think of it as an arrow pointing in a certain direction. If you've ever studied physics or high school math, you've probably encountered the idea that a vector has both a magnitude and a direction. In data science, vectors represent data points and features in datasets. A vector can exist in an n-dimensional space, even though we live in a 3D one. To give a better understanding, let's say we are making a housing price prediction linear model, and there are 10 features, so our data points represented with vectors but exist in an 11-dimensional space. In linear algebra, we usually represent vectors in a column format like this. So let's look at some basic operations that we can do on vectors. Let's say we have a vector 2, 1 and another vector 1, 2. To add the two, we just add their corresponding xy coordinates together to get 3, 3. Graphically, for adding them, we move the tail of one vector to the tip of the other vector, and we get 3, 3. Another important operation is scalar multiplication. This just involves multiplying a vector by a number. What happens here is that the vector is either stretched or shrunk, depending on whether the scalar is greater than or less than 1. If the scalar is negative, the vector reverses the direction. So that's all for a refresher on vectors. In the next video, we'll be exploring the concept of vector independence and how it plays a crucial role in linear algebra.